Hi everybody, this is Mr. Salvador. This is video number 3 for Law of Conservation of Mass. As we know already that the Law of Conservation of Mass states that matter can never be destroyed or created during a chemical reaction. It's just transformed into something else, and therefore the mass of the reactants must equal the mass of the product because nothing is destroyed, nothing is thrown away. So for example, if we have this equation right here where it says magnesium plus oxygen leads to magnesium oxide, we know that magnesium weighed 48.6 grams at the beginning. We knew the oxygen weighed 32.0 grams at the end. And when we weighed the magnesium oxide after the reaction, we found it to be 80.6 grams. So does this follow the law of conservation of mass? Well, what is the total mass of the reactants? Well, if it follows the law of conservation of mass, then both the products and the reactants must equal in mass. So what is the total mass of the reactants? Well, it's 48.6 plus your 32, which gives you 80.6 grams of reactants. Now, if we look on the product side, which is the right side of the arrow, we find out that it is also 80.6 grams. So does this equation follow the law of conservation of mass? Yes, it does, because the products equal the reactants as far as mass goes, all right? So now, because we know that the masses have to equal for the products and the reactants, then we can solve problems using it, right? So here's an example. I will only go for a couple of them, all right? So let's say we have a reaction where it's CH4 plus 2O2, and it produces some CO2, some carbon dioxide, and some water, right? And what if we knew that at the beginning, when we started this experiment, we put 65.3 grams of CH4 into a beaker, and we added 16.4 grams of oxygen into that same beaker, and we mixed it, and it produced CO2, and we figured that out to be 40.3 grams of CO2, but we don't know how much water it produced. So your job is to predict the minimum amount of water that will be produced from the reaction above. So if we know that the mass of the reactants must equal the mass of the products, all we got to do is use math, right? So we know both reactants, we know both weights. So if we add them together, we get 65.3 grams plus 16.4 grams, and we get 81.7 grams, all right? Now we know, again, mass of the products has got to equal the mass of the reactants. So we know if the reactants weigh 81.7 grams, the total mass of the products, right side of the arrow, also must equal 81.7 grams. So we know that the mass of the water must equal the mass of the reactants, which is 81.7 grams, minus what we already know about the products, which is CO2, which is 40.3 grams, and that'll get us the water. So 81.7 grams minus 40.3 grams from the CO2, and that'll equal 41.4 grams of water that was produced. And we know this because, again, the law of conservation of mass says the reactants, the mass of the reactants must equal the mass of the products, okay? So that's all in all that I wanted to mention that to you. The three questions following will be dealing with this. So always keep in mind the mass of the products must equal the mass of the reactants. So you should be able to determine what the missing weights should be. All right. Have a great day. If you need more help with this, go to tutorials. We have one that's all day. We also have mine that's in the afternoons. So whatever you're comfortable with, that's the one you should use. I highly suggest, we're getting near to the end of the semester. Try to get your grades up. All right. Have a great day. This is Mr. Salvador. Have a good day.